Hello everyone, welcome back to the lecture series of numerical methods. In the previous video, we have understood what is trapezoidal and Simpson's rule, when they are used, and how these forms have been derived. In this video, we will purely practice some questions based on trapezoidal and Simpson's rules so that you have a better understanding of these methods. Let us taking a quick recap of what we have done in the previous video. Firstly, we have derived an equation number star which was known as Newton's court quadrature formula, and this is a general formula which will be helpful in deducing trapezoidal and Simpson's rules. Taking the value of n equals to 1 in equation number star, we have derived trapezoidal rule, which is generally written as this. Now note that the lower part of the integral and the upper part of the integral have difference h only, and when we generalize this trapezoidal rule from initial point to the terminal point, this becomes composite trapezoidal rule. And in Simpson's 1/3 rule, we use n is equals to 2 in equation number star, and the general form of Simpson's 1/3 be this. Now note, the lower and upper part of the integral have difference 2 here. And if we generalize this Simpson's 1/3 rule from initial point to the terminal point, it becomes composite Simpson's rule. If you are having any little bit of doubt about this trapezoidal and Simpson's rule, before starting the questions on these topics, make sure that you have at least have a basic understanding of the derivation of this equation. You don't need to remember all these derivation. The point here is, when you see the derivations, you have a feeling how these equations are molding and how we are using these in the questions. Whenever you are given a simple question to solve, you can directly use this equation and put, but whenever the equation is lightly molded, at that time the theory part of these methods play a very helpful role, because it will make you to understand the questions in a better way, and you will have the feeling how you have to solve that question. Now quickly moving to the question based on these methods. The question here says to evaluate this integral using trapezoidal and Simpson's 1/3 rule, and we have to compare these results with actual values also. Let us quickly start this question. Firstly, we have to divide this interval into 6 equal parts, each of width h is equals to 1. That is the table with the values of x and y's be this. Now firstly, we need to solve this question with the help of trapezoidal rule. Integration from 0 to 6 of 1 by 1 plus x square is equals to, the general form of trapezoidal rule says h by 2 into y naught plus 2 times rest of the terms till n minus 1, and in the last yn. Putting the values of y's from the above calculated table, it will be 1 by 2, as we have considered the value of h is 1 plus 2 times 0.5 plus 0.2 plus 0.1 plus 0.0588 plus 0.0385 plus 0.027. This value will be equals to 1.4108. Similarly, we can calculate the Simpson's 1/3 rule, integration from 0 to 6 of the given function is equals to, the general form says h by 3 into y naught plus 4 times the odd terms, which is y1, y3 and y5, plus 2 times the even terms, which is y2 and y4, plus the last term, which is y6. Putting the values of yi's, this will be equals to 1 by 3 into 1 plus 4 times 0.5, 0.1, 0.0385 plus 2 times 0.2 plus 0.0588 plus the last term, which is 0.027. After calculating, this value will be 1.3662. Also, we are asked in the question to compare the results with its actual value. For finding the actual value and the integration of the given function is tan inverse x. This value will be tan inverse 6 minus tan inverse 0, which will be equals to 1.4056. Since we need to compare the actual values by the trapezoidal rule and Simpson's rule, so the error in trapezoidal rule be the actual value minus the calculated value, which will be equals to 0.0052. Similarly, the error in Simpson's rule be actual value minus the calculated value, which is equals to 0.0394. In this question, we were simply asked to calculate the integral value with trapezoidal and Simpson's rule. There was no condition imposed. So by default, we have taken width h as 1 and divided the interval into equal parts. Let us try another question where we are asked to use trapezoidal rule to estimate the given integral, but taking the number of intervals as 10. Since we have to divide this interval 0,2 into 10 equal parts, so we have to take the value of h accordingly. Let the value of y here is e to the power x square and n is equals to 10, which means the value of h will be b minus a divided by n, which is 2 minus 0 by 10, and the h value be 0.2. The values of x and y will be, and by trapezoidal general rule, which is equals to h by 2 into y naught plus 2 times rest of all the terms till y9 plus the last term. And using the values of yi's here, this will be equals to 0.2 by 2 into 1 plus 2 times 1.0408 plus 1.1735 plus 1.4333 plus so on to y9 plus the last term 54.5981. Calculating all these terms, this integration value will be equals to 17.0621. Let us try the similar type of question but with the help of Simpson's 1/3 rule. In this question, we are asked to use Simpson's 1/3 rule to find the integration by taking 7 ordinates. Now in this question, we are not asked to take 7 intervals, rather we are asked to take 7 ordinates, which means we have to divide the given interval into 6 equal parts. So dividing the interval 0,0.6 into 6 parts with the width h as 0.6 minus 0 whole divided by 6, which is equals to 0.1. Now we have to calculate the value of y, which is equals to e to the power minus x square. So while calculating the table, firstly we will make a row for x values, then we will make a row for the values of x square, and then we will calculate the value of y. I have used this extra column x square just for the convenience. If you are fine with the calculations, you can directly find the value of y and skip the value of x square here. Now by Simpson's one-third rule, the integration from 0 to 0.6 of e to the power minus x square dxb h by 3 of y naught plus 4 times the odd terms, which is y1, y3 and y5, 2 times the even terms y2, y4 plus the last term. Putting the values of all these, this becomes 1 plus 4 times 0.99, 0.9139 plus 0.7788 plus 2 times 0.9608 plus 0.8521 plus the last term, which is 0.6977. Calculating these terms, the final answer will be 0.5351. So I hope you have made an understanding how you have to solve the question based on trapezoidal and Simpson's rule. Here are some practice questions for you all. I hope you can do these questions easily now. If you still found any issue and have any doubt, do let me know in the comment section. And if my efforts are helping you, do show some love to my videos and don't forget to share it with your friends. Happy learning!